Okay, so this is going to be a tutorial on how to use the Prusa slicer. As you can see, this is the default screen, and we can rotate around the plate using our left click. We can also zoom in and out, mouse button, and to move without rotating, that is our right click. So to start, we need to import a file. To do that, we go to File, Import, and then Import STL. The first option is fine. And here you can see I have many STL files that I use to print. Today, I will be demonstrating on this chopper model. So once your model has loaded in, it should look like this. And if there are any errors that need to be fixed, there will pop up a little exclamation mark here, which you can click and Windows will automatically repair your model for you. This model is already perfectly fine, and as you can see, there is no exclamation mark. So the first things I do when I import a model are look at the rotation and the scale factors down here in the bottom right corner. The rotation is pretty simple. You can input a amount of rotation you want to put in, a degree of rotation, or you can click on this rotate tool that lets you rotate your model depending on which one you choose. With the scale factor, you can input a number, any number, honestly. You can do it 50%. Obviously, it'll make it smaller. You see if we put in 150, it'll make it bigger. You can make your print bigger, smaller, as long as it is big enough to print and not too big that it is over the limit of the printer. So if I were to say 1,000, if I were to say 1,000, it's always going to tell us that the object is outside of the printer because it's too big. So usually you want to keep your prints within, I would say, like a 4" by 4" split. One more thing to mention, you do not want to have your print very close to the edge because the tool will not be able to travel that far off the print bed, and so that will cause a error within the print. Another thing that we can look at is this option right here called Place on Face. This option basically lets you click on a face that is flat, most likely flat, and you can make that face to be the bottom of your model. This option is very useful for any print that you're going to do that have many different faces and not an exact flat bottom. With this print, obviously we have this flat bottom right here that I can click on to make it the bottom of the print. But some models you can't find that, so you can click on this and you can just find an orientation for your model that looks the most optimal to print with. Obviously, we're going to be printing like this. So once your model has been oriented and you like the way it's oriented, you can choose your print quality right here. You have all the way up from ultra detailed to 0.3 draft. Usually I print with draft because ultra detail isn't worth the time and the weight, and it also has a higher margin of error because of how fine the printing is. If you're printing for a class and you want a lot of detail in your model, you can 4.15, which is a very good quality that you can use to print detail with. Another thing that we need to change is also the infill. Again, we have from 0% to 100%. I do not recommend using anything over 30% because it is just not worth the time and it'll just take up too much filament. Also, again, don't use 0% because there needs to be something on the inside of the print for the print to be stable. So I recommend using 10 to 15%. And sometimes I do 20% if I want a very solid print. Today, we're going to be using 10%. So also one more thing to mention with the print quality and the infill is that the lower the print quality, the more time it'll take to print. And the other way around, the higher the infill, the more time it'll take to print. So you just want to find the perfect balance in between your print quality and your infill to find the lowest time for your print possible. The next thing we do is generate supports. Supports help us or help the printer print anything that is an overhang because the printer, it's not Minecraft, so we can't make things float. So we need to generate supports and we just generate supports everywhere. And then once we slice, we can see that these supports will be generated on anything that is a overhang. So anything that is hanging off. And as you can see, there is a lot of supports on this model, and this will be very complicated for us to take off. So what we can do is we can go to print settings and we can go to support material. And then right down here for option for support material and wrap, we can go to style and we can go to grid, change that to organic. Organic supports are going to look a lot different, and I like to use organic supports more because they use a lot less filament and they print a lot faster. This will cut down on your print time significantly. And other ways to cut down on your print time, like I've talked about, is just upping your quality or lowering your quality and upping the size of the extrusion and also lowering your infill rate. So right now our print is at 3 hours. But for example, if I wanted to print this in more quality, I could do like 0.1 detail and I were to slice this again. It's going to take a little bit longer to slice and you will see in a minute here that the print time is going to be a lot longer. Okay, so it has sliced and you can see down here, it jumped from 3 hours all the way to 10 hours. So obviously it is a lot more optimal to be printing at a lower quality and just sanding it down later. If you really want that detail and you have the time on your hand, you can print at a very high quality. I don't very much recommend it though. Okay, so once you have all your settings and you are happy with how your model is looking, you can go down here to export G code and you can just export it anywhere you want. Usually I export it straight to the SD card that comes in all of the Prusa 3D printers. Okay, so here are some examples of some models that need repairs. As you can see, there are exclamation marks next to each of the files. If you click on them, the Windows will automatically repair these files for you. Some of the repairs might take a little bit longer, just depending on how complex your model is. If it's taking a while, I usually go and do something else and leave it running, and then it will repair on its own. But once they all repair, you can go about doing your setup again. So as you can see, all my models are repaired. I don't see an exclamation mark, so these are fine to print. Some things to note here with these models are that these are very, very high quality, and it might be a little hard for your printer to print these. So most likely you would want to either up the size of these models, or you can up the quality, which will just take more time to print. So another thing to remember is that if you are printing multiple things at once, you want to orient your models in a way that it is most efficient for your printer to move. So right now we just have all of these models in a sort of a jumble. But if we were to orient our prints in a better fashion, meaning if we line them up closer to each other, they're in like a little grid shape, they're more organized. If we were to put them like this would be a lot easier for our printer to print because it doesn't have to move as much. Because if this was all the way over here, the printer would print here and then have to move all the way down here to print this one. So we just want to put our prints very close. Obviously, we don't want to put them touching each other because then the tool paths will collide and the computer will get very confused and it'll mess up your print. One more thing to mention here is that we do not want to print very small details such as this pencil on this model right here. This line right here is way too fine of a detail for printers to print, and it will just mess up your print overall. You will also be able to see this when I slice this file. So when I slice this file, we see a couple problems. Right here, it says warning empty layer between 12.5 and 13.4. If we want to see which layer that is, we can use this bar right here, and we can roll it down all the way to 12.5. So on this model, I think the problem is either going to be on this disk right here or on this square right here. This is just a problem within the designing software, whatever 3D designing software you used. You maybe had a floating bit to your model, and you'll just have to go back into the 3D designing software, whatever you used. If it was SketchUp, if it was Rhino, just go back and try to fix your model. And the next problem we will see, as I was talking about, is this model right here. That pencil is gone because it was way too fine of a detail. So the printer did not want to print that. Obviously, if we up the detail and we slice it again, the pencil's back. But if we look at it, it's only like 2 extrusion lines. So it's going to be very delicate. And obviously, since this is an overhang, you're going to have to generate supports. So then once the supports are generated, we're going to have to rip those supports off. And since it is such a small print, it's going to just rip off, and it'll be very hard to take off the supports without breaking your model. So you do not want to print very, very fine details unless you are making the print very big. Okay, so this concludes my tutorial on the Prusa slicer. In the description, I will have linked a file for the model of this chopper that I used, so that if you want to, you could try to follow along with the video and do the same steps.